Hello, we are Taeyeon Dayoung Im, Chani Lee, and Sangyeon Lee from Team 5. We will be presenting our software requirement specification for our project. First, we will be introducing our system. The name of our system is Convrio, which means a musical direction with spirit or with figure. As musicians, we need a case that can provide appropriate protection for our instruments. Although traditional cases are functionally great for this purpose, they do not provide convenience as musicians need to provide continuous care for the instrument. To provide such convenience for musicians, we have come up with Convrio, an innovative case system that provides useful functionalities for musicians. When using existing cases, everything had to be managed and controlled by the user himself. They have to take care of the condition of the instrument and had to prepare all accessories like tuner and metronome. But we were able to automate the majority of the features using IoT. Our ultimate goal is to help musicians by minimizing all these tedious works that he or she should care about. All you have to do is practicing and improving your performance. Next, we will be introducing our system's functional requirements. First, the case shall maintain the temperature and humidity set by the user. Since violin is built with wood, they are sensitive to temperature, moisture level, and other external environments, requiring continuous care. The system should recommend the temperature and humidity value for violin. Second, the system shall record only the sound of the user accurately when the user performs in a music session. By attaching a small device with vibration sensor on their instruments, only the sound of that specific instrument is recorded, and users can review their performance efficiently. Third, for a situation in which the user may have lost the case, Convrio provides functionality for tracking the location. Users will be able to track the location of their cases with their smartphone application in real time. Next, the tuner in the case shall show the correct notes played by the user, and the metronome in the case shall play the beat according to the speed and meter set by the user. Lastly, the system shall send notifications through the smartphone application when charging the case is needed.
Our first use case can always be useful since it is about maintaining the ideal temperature and humidity. Here, the actors would be the Convrio case, user, and the smartphone application. We have indicated the primary actor by coloring it as red. When this scenario goes successful, the internal temperature and humidity of Convrio case would be maintained in ideal conditions for the instrument. With this user diagram, we illustrated how our main flow and its branch proceed. Sensors in Convrio case detect temperature and humidity, and the internal condition management system maintains it in adequate range. Users can set desired values by a smartphone application, and current status will be informed by display on Convrio case and smartphone application. This is the sequence diagram for the use case 1. Since this use case is all-time working, the sequence is in the loop. The temperature and humidity sensors send the current status of the case to the management system. If the condition is out of the desired range, the management system controls the internal condition into an adequate range. This is the user manual for use case 1. Optimal temperature and humidity for violin are automatically set in default settings. To change the temperature and humidity settings manually, a user can use a smartphone application. Click on the current status on the main page. Users can change the temperature and humidity settings as they want by scrolling up and down. After setting the values, clicking the Save Settings button will save the settings. You can see the current temperature and humidity on the smartphone application and on the case display as well. Next case is recording only the sound of the user in the music session. It is hard for music players to recognize their own sounds in the music session, so we provide a feature that users can record only the sound of their instrument. Successful end condition is that the users listen to their recorded sound and monitor their performance. The main actor here is an add-on device that needed to be attached before the recording. This is the use case diagram. The attached add-on device detects oscillation of the instrument and sends it to the recording system of the case. Then, the system converts it to the audio file and sends it to the smartphone application. The user finally can monitor his or her sound on the application. This is the sequence diagram for the use case. First, the user clicks the record button on the add-on device. Then the add-on device transfers the vibration of the instrument to the recording system of the Conbrio case. Then the recording system processes it into the audio file and sends the audio file to the smartphone application. This is the user manual for use case 2. First, check if the add-on device is connected with the Conbrio case. The green light turns on when it is connected properly. Attach the add-on device on the violin and press the record button when you are ready to play in the music session. When the session is finished, press the stop button on the add-on device. You can get the notification on the smartphone application when the audio file is fully loaded. Now you can listen to the music and monitor your performance.
Our third use case is finding out the exact location of the instrument case. This use case can happen when the user wants to find where his or her instrument case is. Actors will be the GPS server, user, smartphone application, and the GPS system of Conbrio case. The successful end condition will be a smartphone application telling the user the exact location of the case. The user diagram shows how users will be interacting with the GPS server and smartphone application to find the location of the Conbrio case. The user will request for the location of the Conbrio case, and the GPS server will get the exact location of the case and return it back to the user through smartphone application. This is the sequence diagram for use case 3. The user will first request in the smartphone to find the location of the case. Then, the application will send a signal to get the location from the GPS, and the GPS will send back and forth signal with the case. The GPS will calculate the location and return the location to the smartphone. Lastly, the smartphone will display the location to the user. This is the user manual for use case 3. First, users can click the Find Your Case button in the smartphone application. Then, users will be able to find the exact location of the Conbrio case on the map. Next use case is using tuner. In many situations, musicians have to tune their instrument before playing it or even while playing the instrument. In such a situation, a tuner will come in handy. It helps musicians to tune their instruments precisely by providing information such as frequency about notes. This use case will successfully end when the tuner system tells the user the exact note that he or she is playing. The primary actor is the tuner system in the Conbrio case, and user, add-on device, display in Conbrio case is included as secondary actor. This use case diagram shows actors and their relationship. In order to display the user's note, the add-on device first detects the vibration of the violin. Then, the tuner system calculates it and converts it to frequency. Sequence diagram is quite straightforward. User sound is the trigger for this process. The add-on device will then detect this vibration and transfer it to the tuner system. When the tuner system receives vibration, it calculates the frequency and sends it to the display. Finally, the display simply visualizes its frequency to the user. User manual consists of 3 steps. First, user will attach an add-on device on the violin. If the device is attached properly, then the green light of the device will be turned on. After checking the green light, the frequency of the user's playing note will be shown on the display of the Conbrio case. It not only shows the code, but also shows the exact frequency information.
Fifth use case is using a metronome. Metronome is one of the essential devices used in music, but it is really easy to forget to bring a metronome if you have a lot of musical devices to take care of. So, Conbrio case has its own metronome. This use case ends successfully if the metronome starts to play sound and displays the tick. Primary actor is the Conbrio case, including display, speaker, and metronome system. Also, user is a secondary actor. The main actors, display and speaker, deliver actual content of metronome. Speaker makes a ticking sound and the display shows the tick. To do so, users have to set a metronome and click the start button. Then another main actor, which is the metronome system, processes the user's input and starts the metronome. This is the sequence diagram. When user input comes in, the metronome system of the Conbrio case starts two parallel processes. First process is about the speaker. System will send the signal to the speaker, and then the speaker will start to make a ticking sound. Second process is displaying metronome ticks through the display. This manual shows you how to use the metronome of the Conbrio case. First, users have to open the case to use the metronome. There is also a speed setting button on the display. When you press the start button on the display, the metronome will start functioning. Changed speed setting is applied immediately to both display and speaker. Last use case is sending notifications to user when charging of cases is needed. This use case is useful when the battery of the Conbrio case is low. It automatically sends notification to user's smartphone application, which informs the users that the case needs charging. Successful end condition will be sending notification to smartphone application. And actors are the battery system and smartphone application. This simple use case diagram shows actors and their relationship. When case detects low battery system interact with smartphone applications through notification. Sequence diagram starts with iteratively conveying the state of the battery. While looping, if low battery condition is satisfied, the battery system will send the notification to the connected smartphone application. Then, the application will show the notification to the user. Manual is very simple. User will just get notification when the Conbrio case detects low battery. Lastly, we will be presenting the quality attributes of our product. The target user of our product is musicians or people who own musical instruments. The training required for the users will be simply learning how to use the functionality of the Conbrio case and the smartphone application. Next, there will be a manual for using the Conbrio system. This will be given to the users, and this manual will also be posted on the official website of our product. Moreover, it can be viewed later in the smartphone application. For hardware consideration with the operating environment, the smartphone application will be functional in both Android and iOS. The hardware used for the system will be the embedded Linux and display for Conbrio cases. The recording will be saved in the internal storage of the smartphone. Lastly, for security purposes, users have to tag the smartphone on the NFC sensor of the instrument case to access all of the functionality of our product.
This is the end of our slides. Thank you for listening.